teacher. Hello, students. Welcome to today's lesson on the notion of sets. In our last lesson, we learned how to define and describe sets using proper notation. Today, we will study the meanings of empty, finite, and infinite sets. We will also learn the difference between equal and equivalent sets. We have a lot of material to cover today, students, so let us begin. It is possible for a set to contain no elements. For example, if the set of A includes X, where X is a real number whose square is -1, there are no elements of X that can fulfill this set. We call this an empty set or null set. An empty set is denoted by these symbols. Other sets are referred to as finite sets or infinite sets. A finite set contains n elements, where n is some non-negative integer. If a set S is finite, then we denote the number of elements of S by n of S. For example, if S is the set of elements -1, 0, and 1, then the number of elements of set S is 3. If a set is not finite, it is called an infinite set. For example, if B is the set of elements 2, 4, 6, 8, and so on, then B is an infinite set. In addition to sets, we can also have subsets. Let us look at two sets, A and B. The set of A is the set of elements 5, 8, and 11. The set of B is the set of elements 3, 5, 8, 9, 11, and 13. Since each element of A is an element of B, we say that A is a subset of B, denoted like this. If the set of A also included the element 10, A is no longer a subset of B because 10 is not an element of set B. For any set A, null set is always a subset of A, and A is always a subset of A. The power set of A denoted by P of A, is the set of all subsets of A. For example, the set F contains the elements -2, 2. The subsets of F are null set, the set containing -2, the set containing 2 and F. Therefore, the power set of F is null set, the set containing -2, 2 and F. Finally, A is said to be a proper subset of B if A is a subset of B and B is not a subset of A. For instance, if A is the set of elements 0, 1, and 2, and B is the set of elements 0, 1, 2, 3, and 4, then A is the proper subset of B. Students, for each set in the left column, please choose the sets from the right column that are subsets of it. There may be more than one subset for each set.
Students, let's get ready. Begin. Let's get back to our lesson.
Hello, everyone. I am sure that you did not find that activity too difficult. For A, both empty set and the set containing 3 are the subsets of the set which contains the elements 1, 3, 5, and 7. For B, the empty set and the set containing H and I, as well as the set containing J and G, are subsets. For C, the empty set and the set containing H and I are subsets. For D, the empty set is the only subset of 2, 8, and 9. Did you remember that null set is a subset of every set? Good work, students. When we compare the elements of 2 sets, it is important to distinguish between equal and equivalent sets. If 2 sets have exactly the same elements, they are equal. Let E be the set of elements 2, 3, and 4. F is the set of elements 3, 4, and 2. Because E is the subset of F, and F is the subset of E, we can say that E equals F. If 2 sets are not equal, they can still be equivalent. Consider these 2 sets. A is the set of elements C, D, and E. B is the set of elements 1, 5, and 7. Obviously, these 2 sets do not have the same elements, but they do have the same number of elements. Each element of A can be matched with exactly 1 element of B. If there is a 1-to-1 correspondence between 2 sets, A and B, then A and B are equivalent. Note that equal sets are always equivalent, but equivalent sets are not always equal. We have time for one more activity, students. Which of the following pairs represent equal sets, and which of them represents equivalent sets?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. The sets X and Y are both equal and equivalent. Although the set X lists multiples of its elements, we consider only one value for each. The sets A and B are both equal and equivalent. When we study the set B, we find that the only elements of X that satisfy the properties of the set are the elements 1 and 2. This means that A is equal to B and therefore equivalent. The sets M and N are also both equivalent and equal. If X is a factor of 6, then 6 must be a multiple of X. M is a subset of N, and N is a subset of M. Students, today we have learned that sets can be empty, finite, or infinite. We have discussed power sets and proper subsets. And we have learned to distinguish between sets that are equal and those that are equivalent. In our next lesson, we will study operations on sets.